Lesson 16, Median. The median is a measure of central tendency, or average of the data. The median measures central tendency by finding the center divider of the data. That is, the median is the value such that half of the data values are less than the median, and half of the data values are greater than the median. The median is found by sorting the data values from the minimum to the maximum and determining a value for which half of the data is less than and half of the data is greater than that value. The onevarstats command on the TI-84 calculator calculates the median for a list of data values and denotes it by the abbreviation MED. For instance, calculate the median exam score for a student that receives scores of 4, 2, 5, 3, 0, and 4 for the 6 problems on their Unit 1 examination and interpret the result. Well, we could use the TI-84 calculator to calculate the median for this data, and after we do that, we will then use words to interpret the result. In order to use the calculator to calculate the median, we first have to enter the data values into a list. To enter data into the TI-84 calculator, we press Stat, Enter, to enter the list editor. But here we see List 1 already contains the data for the scores that the student received on their Unit 1 examination. So the data is already entered in List 1. All we need to do is do the onevarstats command to calculate statistics, such as the median. So we press Stat, right arrow to calculate, and then press Enter to select the onevarstats command. Now we tell the calculator that the data is in List 1 by pressing second and the number 1, and List 1 appears. To execute this command, we press Enter, and various statistics are displayed. The median is not on the first screen, so to see the median, we need to press the down arrow to reveal more statistics. And there, you'll see that the median is displayed. The median is denoted with the abbreviation MED. In this case, MED equals 3.5. So, now that we have the median calculated, we can say the description. The median Unit 1 examination score for this student is 3.5. But descriptions just merely use words to report the result directly from the data. In this instance, we wanted an interpretation. An interpretation gives us more than just a description. The interpretation explains or gives meaning to the result. The median measures central tendency by finding the value such that half the data is less than and half the data is greater than that value. So this is how we interpret the median. Thus, half of the student's Unit 1 examination scores are less than 3.5 and half are greater than 3.5. To illustrate this, we could take the student's Unit 1 examination scores and display them on a number line. The median of 3.5 is the center divider of all these data values. The median splits the data in such a way that half the data values are less than the median and half the data values are greater than the median. In this case, this student had 3 out of their 6 scores, or 50%, less than a 3.5. The other 3 out of the 6 scores, or 50% of the scores on this test, were greater than 3.5. Although the median is defined as the value where half of the data is less and half of the data is greater, for certain situations or specific population or sample sizes, this precise outcome cannot be achieved. For instance, when the population size or the sample size is odd, the data values cannot be perfectly divided in half. In this situation, a reasonable approximation for the median, or center divider, is selected. So if we were to have an odd sample size of, let's say, 5 pieces of data, we cannot divide the 5 pieces of data perfectly in half, where half would be less than and half would be greater than the median. In this case, the median best approximation would be the actual middle data value, and that middle data value will be representing our center divider or median. Here, it's about half the data is less than, and about half the data values are greater than, but it's not exactly a 50-50 split. This third value in the middle that we take to be the median only has 2 data values less than it, and 2 out of the 5 is about 40%. It also has 2 data values greater than it. 2 out of 5 is 40%. The reason it's not exactly 50-50 split is because the median is taken to be equal to that center data value. And that one data value is 1 out of the 5, or 20%. So therefore, when we have small sample sizes like this, the approximation is not very good. But if the sample size was to be much larger, like 51 pieces of data, that one data value in the middle, taken to be the median, is just 1 out of the 51 pieces of data, which is a little less than 2%. And that leaves about 49% less than it, and the other 49% greater than it, which is a much better approximation. So, as long as the population size or the sample size is sufficiently large, this imprecision is negligible. Whether the median indicates the exact center divider of the data or a close approximation, it will always be the case that at most 50% of the data is less than the median, and at most 50% of the data is greater than the median. The percentage of the data that is neither less than the median nor greater than the median is the proportion of the data that is equal to the median. Unlike the mean, the median is resistant to outliers. That is, the median does not need to adjust for extreme data values in order to indicate the center divider of the data. So to illustrate this, we can look at a sample where the median, or center divider, splits it in half, where half the data values are less than and half the data values are greater than. Now, if the minimum data value was extremely low, much farther away from the rest of the data values, it still doesn't change where the center divider is. It's still right between the second and third data value in this example. And it doesn't matter what the maximum data value is. The maximum data value can be extremely higher than all the rest of the data. The median does not adjust. It still splits the data in half, where half the data is less than and half the data is greater than. It doesn't matter what the extreme data values are. So, when outliers are present in the data, the median is the preferred method for measuring central tendency.